Hello, my name is Andy Schweitzer, and this is a video on the pH system. The question says here, how do I quantify the level of the acidity of something? How acidic is something? You should be aware that H3O plus ions are what makes something acidic, and hydroxide ions are what makes something basic. If we have a greater amount of H3O plus ions, then we are going to be acidic. If we have equal amounts, then we will be neutral. And if we have greater hydroxides, then we'll be basic. All right. As we go through this topic of acids and bases, you should be aware that water has a unique property where it actually auto-ionizes, and this is something that is very important for full understanding of what's actually going on. We have H3O plus ions, and I am going to erase this little bracket right here, and just because I don't want that there. And I have my hydroxide ions. So in water molecule, we have a beaker, all right, and we have a water molecule here. It is two of them actually. Another one here. These guys are going back and forth between H plus ions, which is meaning H3O plus, and hydroxide ions. With that being said, the concentration of these two guys together, this is an equilibrium system. The K value equals the equilibrium constant, the concentration of my products or my reactants, the concentration of the H plus times the concentration of the OH negative, and there is nothing to measure here concentration-wise because it's a liquid. So in this case, my K value, which is equal to KW, 1.0 e to the negative 14th, equals the concentration of my H3O plus ions times the concentration of my hydroxide ions. So together these two concentrations cannot exceed, we'll have to equal this value here. With that said, you should note that if this guy goes up, then this one has to go down, and vice versa. If this one goes down, then this one has to go up. So it's kind of like a teeter-totter type situation. If it's in the middle, okay, where they're both equal, hence if they're equal, this is a neutral solution, then the H3O plus ion equals 1.0 e to the negative 7th. And this guy also equals 1.0 e to the negative 7th. So if these two concentrations are equal, then they'll still, again, multiply to that, then these two things, well, again, like I said, they're equal, okay? I like to keep in mind this number, 1.0 e to the negative 7th. I know that's the midpoint. So in any situation, if your H plus ions concentration were to go above that value, we would be acidic. If we were to drop below this value, all right, then we would be basic. You should understand that conversely, if your H plus ion concentration goes up, then your hydroxide ion must have, and I'll kind of put this one here, if this guy goes up, then this guy must have conversely gone down below that value. And if your basic, like I said, goes down, then this guy must have gone up. So these two are locked, these two are locked, okay? So if I want to tell how acidic something is, really I want to know quantitatively how far have I gone above or below the midpoint. So for an example, I could just say if I have an H plus ion concentration equaling 1.0 e to the negative 4th, okay, I have gone above this value, which means my H plus has gone up because this number is bigger than the midpoint, then my hydroxide must have gone down. And that is going to be 1.0 e to the negative 10th. Okay, molarity and molarity. So this is the hydroxide ion concentration, and this is the H plus ion concentration of a particular water solution. This water solution is in fact acidic. I know that right away by looking at either of these values. These are values of the same solution, keep in mind. So I know that this is acidic because it went above that value. I know this is basic because if the basicness hydroxide go below that value, then that means H pluses must have gone above it. Hence, I am acidic. Now, how do we give a level of acidity? I could simply just state right here. This is my H plus ion concentration. That's how acidic I am. This is my basic concentration. This is how basic I am. But people were looking for something a little more simple, okay? Something with a scale, where this level would be acidic, and over the long end, this level would be basic, and maybe the middle would be neutral. Something that we could grasp our whole head around, from start to finish. And that ended up being the pH system, okay? The pH system looks like this. Now, the pH system tracks I'm going to go back here a second, okay? The pH system is going to track the H plus ions. And the pOH system, which you may not be familiar with, is going to track the hydroxide ions. These are locked, and they're locked by this mathematical equation right here. If I know my hydroxide ion concentration, I can plug it in, my H plus ion concentration, hydronium, and if I know this one, I can plug it in, divide it out, and I get this guy's concentration. Conversely, if I have the hydroxide ion concentration, I can divide it out, and I get my H3O plus ion concentration. So they're locked by this number. They teeter-totter, and this is a very important equation. So with that being said, let's back up here. The pH system right here tracks the H plus ion concentrations. So this is the most acidic right here. This is the most acidic we can have, all right? And this is the most basic I can have. Each of these pHs represents a concentration of H plus ions. And over here, this is give it to me, there we go. This represents the hydroxides. Again, they are also locked. A 0 pH is the same as a 14 on the pOH. This is the most acidic. This is the most basic, and these numbers are equal. A 14 on the pH is equivalent to a 0 on the pOH. Notice they are mirror image of each other, and these are both neutral. Okay. Again, every value here on the hydroxide pOH scale represents a concentration of hydroxides. Now, this is not a linear scale. And I'll give a quick example of what I mean by a linear scale versus a exponential scale, which is that of the pH and pOH system. Example I give in class is, let's just say hypothetically a kid works at McDonald's, the old Golden Arches, the Big M, all right? And let's just say this kid hypothetically in a 2-week pay period makes money, $200. Okay, in a 2-week period. All right, and let's just say hypothetically that after his first 2-week period, he gets paid again, and McDonald's makes a little mistake, and they take his check and they move the decimal point over one spot to here, and now he makes $2,000 in a week. Okay, this is a bit of a mistake. He made $1,800 extra because of this mistake. All right. Now, let's say on the next 2-week period. All right, so now we're in just beyond a month. All right, they make the mistake again, except they continue the mistake. And rather than making the same, it bumps 2,000 to 20,000. Okay, the first mistake lets Mr. Johnny here, let's just say Johnny working at McDonald's, can pretty much go to the mall and buy whatever he wants with this check. Okay. Now he made an $18,000 mistake, and he can pretty much go buy just about whatever car he wants. Okay. All right. let's keep going. Johnny's kind of interested. What's going to happen next? Okay, well, now we're starting our fourth week, 2-week period, or 2 months. The mistake happens once again. Now he goes from being able to buy a car to be able to buy pretty much where we live, just about any house that you want to be. Now, it wouldn't be in every part of the world, but in our part of the world, would buy a pretty nice house. $180,000 mistake. All right. Okay. Getting a little curious, he waits just past this. This is his 5th pay period, and he is going to get a $2 million bump here. So not only could he buy a house the last time, this time we have a $1.8 million mistake. He'd be able to buy the McDonald's, most likely. All right. The next one, he'd be able to buy pretty much every McDonald's in the Midwest, Wisconsin, Northeast Wisconsin. If it happened again, well, this would be, so this would be $20 million. And you can say that is $18 million mistake. And then here, another 2-week period, he'd be able to $200 million. And he'd be able to buy pretty much every McDonald's in maybe the state or close to. So we're talking just simply 1, 2, 3, 4, 5, 6, 7 pay periods. An 8th pay period, he would become close to buying most of them in the Midwest United States. So we have here is a situation that's called an exponential situation like this. And in equal amounts, every pay period, you'll see that the change increases dramatically. And eventually, even one more pay period, he'd be able to buy McDonald's entirely. So either way, this is a simple example of an exponential function. Unlike a linear function, which would say, okay, if you're walking, let's just say linear-wise, you're walking, okay, at 1 mile in 10 minutes, okay? And 2 miles should take you 20 minutes. 3 miles, assuming you don't get tired, would make you 30 minutes. And it just continues on. 4 miles, 40 minutes. This is a pretty common situation in science. It's a linear relationship. It would be described by this mathematics and y1 over y2. Of course, we'll talk more about that later on. But it'd be simply 1 mile in 10 minutes. You could put your time here, distance or time here. You could solve for the missing variable. Either way, it's a linear, very simple. All right, moving back to the situation with the ions, you'll notice that each of these, this pH represents a concentration. That concentration happens to be 1.0 molar moles per liter. This is 0.1 moles per liter. This is 0.01 moles per liter. This is 0.001, and this just continues on. So pH is not representing a linear relationship. The difference between 2 points is the same, but it increases as you go. It's power of 10. This guy here would be 0.0000001, 2, 3, 4, 5, 6, 1. And that will equal this guy right here. They're all the same. These two therefore equal this guy. On the bottom here, you'll notice that this represents hydroxides. So this would be, down here would be 1 molar, and then 0.01, 0.001, and it would increase up to 0.0000001. Now, as you go up higher, this is going to add additional zeros all the way up to the fact here is 1.0 e to the negative 14th moles per liter. All the way down here, 1.0 moles per liter. So as this guy is maxed out, this guy's at its minimum. As this hydroxide is maxed out, this guy's at its minimum. All right, so again, let's quickly review. I got interrupted there for a moment, but all these concentrations are powers of 10, high amounts here, low amounts here. There are occasions you might see a situation of a chart that might look like this, where we have our H plus ion concentration, our hydroxide ion concentration, and you would have a little chart where it shows they're divided, where you have on a acidic solution you have lots of H plus ions, but on a basic solution we'd have small amount of the hydroxide and lots of the hydroxide on a basic solution. So this would be a pH of 0 and a pH say a pH of 0, pH of 14, pOH of 0, and a pOH of 14. So very acidic pH value right here, pOH right here. Lots of H plus, very little hydroxides, pH of 7, and they would be essentially equal. All right, quickly going to go through some of the mathematics. All right, we've already dealt with the fact that your Kw equals the concentration of the hydroxides, concentration of the H3O plus ions. At this point here, we have the pH plus the pOH equals 14. To go from pOH to P concentrations, the mathematics to go up and down between these two is the same. Either side is the same. So to go down, either one of these would be the negative log of the concentration equals the pOH. And then to go back up, you do the 10 to the negative pOH equals the concentration. Examples here, I guess. We'll do a couple of examples on the next page. These are the mathematics. Have your calculator ready. So for a common question here might be this. Okay. Any solution will have each of these values. Every aqueous solution has all these values. So let's just say that I give you the H plus ion concentration is 1.0 e to the negative 8th. Okay. Immediately, because I know that 1.0 e to the negative 7th is the midpoint, that means my H plus concentration went down. Therefore, if my H plus goes down, my hydroxide must have gone up. And at this point, that means I am going to be basic. 1.0 e, well, let's calculate this one. I'll show you the answer here. E to the negative 6th. I got this value from using this equation right here. Flip from this to this, and we have 1.0 e to the negative 14th equals concentration of H plus ions, concentration of hydroxide ions, and this guy right here is 1.0 e to the negative 8th, and x equals 1.0 e to the negative 14th. Divide it out, 1.0 e to the negative 8th, and x equals. Now in this case, we subtract this, we divide these two guys and subtract the exponents, and that's where I get this value here. All right, to get the pH, I'd want to convert my H plus ion to pH, and I will use this equation right here, H plus ion to pH, which is 10 to the negative pH equals the concentration. All right, and in this case, well, I have the concentration. I guess I want to go the other way. I want to use concentration to go to pH. So again, let's review that one here. It's this guy right here. Need the concentration. Negative log of the concentration equals the pOH, or negative log of concentration H plus ions gives me pH. All right, so in this case, negative log. Again, I want to plug in the 1.0 e to the negative 8th, and this will give me my pH, which if you plug it in will be 8. Note that if this is 1, then this ends up being your pH. I could use the same mathematics here, which would be negative log of the concentration 1e to the negative 6th equals 6. At this point, I would note that these two things multiplied together could be plugged in here and would equal this value here. So any of these mathematics should be able to be used. I was given this guy. I calculated that one via this equation right here. I dropped it using this equation. I dropped it using this equation. I could have just easily dropped this to pH, flipped it to POH, and brought it back up with this equation. All of those should be usable. Only other thing that for these guys that I'm sort of reviewing, that's pretty much it. I guess there would be nothing else really. All right. This should be followed up with a few more practice questions. Make sure you're ready to roll. Thank you.